Hai and Assalamualaikum warahmatullahi wabarakatuh. My name is Mohd Daniel bin Mohd Sahid, and today in this video my team and I are going to present about our CSC569 mini project named Java Syntax Checker. Our team consists of 4 members, including me, and the rest are Maisarah Yasmin binti Ishak, Nur Farain Aliyah binti Imran, and Nur Syakilla Ashikin binti Hassan. So what are CC? CC is a compiler generator tools that can be used for us to automatically generate a compiler or interpreter from a grammar specification. It is usually written in Java and it takes a context-free grammar and generate the corresponding Java code for the use of Lexer, which is the scanner that will break the input into token, and also a parser that which will analyze the token stream according to the grammar rules. And in this mini project, the focus is more on developing a simple Java syntax checker by using CC. And the goal is basically we want to design and extend a lexical grammar to recognize Java elements such as keywords, operators, identifiers, and many more. This could help us to understand better about lexical analysis and how source code is tokenized before compilation. Basically, the flow are we will first extending the base grammar file named syntaxchecker.grammar by updating the grammar to implement support for Java specific construct. And then we will test our Lexer with the provided test file in the format of .mj. And lastly, if there is any error, we will debugging the grammar definitions to ensure correct lexical behavior.
Next, I will be explaining the objective of our mini project, which is a Java syntax checker using CC. Our first goal is to develop a basic syntax checker that can recognize tokens in Java-like code through lexical analysis. This means the program should be able to scan the source code and identify each word or symbol as a token. Next, we aim to modify the existing grammar file to support more tokens, including keywords like if, while, and return, identifier like variable names, numbers, and both single number and multi-line comments. Finally, we want to verify that Lexer works properly by testing with MJ files. This test will help ensure that all tokens are recognized accurately and that the Lexer behave as expected. This objective will help us better understand how lexical analyzer works and how compilers begin processing our code. Moving on to grammar file modification. The initial syntax checker was expanded from basic tokens to support Java Essential, including comparison operators, Boolean literals, data types, and varied comment styles. There are 11 tokens that we have added, such as public, true, void, static, float, char, double, final, while, this, and the last one is return. That's all the keywords token that we have added, and we declare it as their own name. Like publics, we declare it as public, and so on.
Run and test the Java syntax checker using a CC. Here is the steps that we follow. First, we open the command prompt in the folder containing syntax grammar file. Then we run this command. After that, this generate the Lexer and parser file after this command successfully being run. After that, we compile the main Java file using java main.java where we write it there. Finally, we test the Lexer with the input file java_test.mj here by running this command. During this testing, we encounter of several errors. First error that we face is unknown tokens. If we saw an error like this line, we should open the java_test.mj file and check the line and column. Fix this issue and repeat this step again. Another error that we face during the debugging process is token partially recognized. To fix this, we open back our syntax checker grammar, update the token definitions, and try to run this step again from the beginning until they have no error. Then we get the output. Test like say it will be repeated until the lesson work correctly and all lines in Java underscore test MJ were successfully processed.
Okay, first we go to the CC folder. And then we search for syntax checker.grammar and also java underscore test.mj. So we open it using a notepad. Java underscore test.mj is a file that has all the coding and we want to identify each token here. Okay, next is a syntax checker.grammar. It has helpers, tokens and also ignored tokens. In tokens, we have added new tokens to identify the tokens by the coding. Okay, so in order to run, we click on the directory md OK, and then we put our command here, which are java-jar lib/cc.jar syntax checker.grammar. We put syntax checker.grammar because it consists all the tokens, the previous token and the added tokens. So we run. We put java c main.java. And then we put the java main less than java underscore test.mj. This code will compare the java test mj with the main. So it will identify all the tokens in java underscore test.mj. End of input, that's mean our token has fully declared in the syntax checker.grammar. Okay, next is challenges and solution. For challenges, we have a token not fully recognized, string literals and character literals, and also token recognized as a white space. So for the solution is token not fully recognized, we add the unidentified token into the syntax checker.grammar. And then for string literals and character literals, we using a hex number to identify the string literal and also the character literals, which are 34 and 39. Lastly is token recognized as a white space. For the solution, we ensure that the intended token is defined early in the syntax checker.grammar.
In summary, this mini project successfully developed a Java syntax checker using a stable CC. It demonstrates how costume lexer can be built and expanded using a grammar definition to recognize a various Java-like token. The lexer now able to accurately process the text file, confirming the effectiveness of the rules or the token rule inside it. Through this project, we gain a valuable insight into lexical analysis and the foundation's role is playing in compilation process. Whilst the project meets its goal, it also reveals some of the challenges and limitations that we face, especially in handling certain type of literals. Here is several recommendations for the future use for this project. To improve the syntax checker, it also recommended to extend token support for floating point numbers, hexadecimals, and binary literals to enhance Java compatibility. String and character literal handling should also be improved, especially to support escape sequence more accurately. Additionally, the grammar structure can be optimized by reorganizing in token definitions to avoid conflict, simplifying complex expression, and ensuring correct token precedence. I think that's all from us. Thank you very much.
So I guess that's all from all of us. Thank you and Assalamualaikum warahmatullahi wabarakatuh.